The production and processing of steel is characterized by a wide range of steel types and processing options. In addition to manufacturing data, a large amount of materials data is generated. At Fraunhofer IWM, we measure and determine such material data in the sheet metal testing laboratory by using different machines and types of experiments. Also, such data is generally quite heterogeneous and anything but easy to evaluate. With the StahlDigital project, we have combined our expertise in the fields of materials informatics and mechanics of materials to create technical solutions to harmonize the heterogeneous raw data and make it interoperable in a data space. This makes downstream workflows such as the determination of materials properties and material parameters for material models much more efficient.
Workflows in material science and manufacturing typically start with gathering experimental data, which is heterogeneous and originates from different sources. Handling such data is cumbersome and time-consuming for engineers. Also, keeping an overview of this data is challenging. Furthermore, analyzing the data manually with self-written algorithms or optimization tools results in subjective interpretations, for example, when determining material properties. This, hence, can result in different simulation results and assessments. The solution is to harmonize data and make it interoperable using semantic technologies. The basis is vocabulary gathered from domain experts, which in total forms a valuable ontology. Using the ontology, our data to RDF pipeline harmonizes experiment data by transforming it into RDF format, a standard data model format for handling metadata. The harmonized data is integrated into the data space and linked to other information, such as specific test series regarding experimental data. Data upload can be automated using an easy-to-use Python interface or via drag and drop. Therefore, metadata is automatically extracted and linked in a meaningful way on the basis of the ontology. The linked data forms a so-called knowledge graph that can be explored to gain new insights. Finally, apps can be developed to enrich the data, for example, with secondary data such as material properties that are automatically determined. In this way, we created the novel semantic material card concept, a framework that automatically extracts material properties from experiments, stores them in a semantic representation, and outputs customized input files for simulation software on demand.
The data space solution developed at Fraunhofer IWM, which is powered by a data space management system, will enable the representation of typical workflows in steel processing, component manufacturing, and component usage in an automated, transparent, and traceable manner. In the future, tedious and error-prone tasks, such as pre-processing heterogeneous data, can be avoided, which can lead to a significant performance boost in the materials engineering field.